Okay, welcome to the second question from the review packet. This is a sinusoidal model function. There will be a question on the common assessment that looks just like this. So, first of all, before we even get started, we need to make sure our calculator is in radians. So if you don't know how to do that, go to your calculator, go to the Home, Settings, Document Settings, right here in Angle, make sure it says radian, and then click Make Default and OK. Now you're ready to go. Okay, here we have a problem where we have the average monthly temperatures in Boston, Massachusetts are shown in this table. So we have January through December, and then the temperatures reported to us in Fahrenheit. Okay, so part A says determine the equation for a sinusoidal function b of t, this is what they're calling it, which can be used to model this situation, and they're going to say let t equal 0 represent the month of January. So let's start right here. So January is 0, and then every month after that we're going to move across, or we're going to increase our t value. So we're going to go February is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, they're asking for a sinusoidal model function, so this is what it's going to have to look like. B of t equals a times sine of bx minus c plus d. That is the form of the function that our answer needs to look like in order to get full credit here. Okay, so we got to go over to our calculator. Keep this table handy in front of you because that's what I'm going to be referencing. Okay, so in your calculator, create a list and spreadsheets page. My first column, I'm going to label my t values, which will represent the month. Or actually, let's just go ahead and call it the month. And then my second column, I'm going to say it's the temperature. Okay, so we can't just write January there. We have to write an actual numerical value. So that's why they told us in this problem that January is 0. And that's why we went through the trouble of labeling all these months 0 to 11. So 0 all the way down to 11. And then I'm going to go back up, and for each month I need to enter the temperature for that month. So January was 29 degrees, February 30, 39, 48, 58, 68. Sorry if I'm moving a little fast. You can pause if you need to. I'm on a computer, so it makes it a little easier. July was 74, 72, 65, 55, 45, and 34. Okay, if you need to, pause the video, catch back up, and then press play again. Okay, so now you have all your data entered. So I'm going to create another page by doing Control Document, and I'm going to add a data and statistics page this time. Okay, once you do that, you'll see this like random scatter plot of the data you just entered. That's okay, yours might look different than mine. It's just a random assortment of dots. On the x-axis, you're going to like move your cursor down here and click. Okay, we need to decide which one is going to be the independent variable or my x variable. Well, the x variable is always the independent variable, like I said, so we need to define which of these is independent. A good rule of thumb is time. A measurement of time is always the independent variable. So I'm going to put month on my x-axis. I'm going to do the same, go over to my y-axis, and put temperature. Okay, so this problem is asking for a sinusoidal model, and when I graph my points according to my axes, I can kind of see the wave function. So this is looking good so far. Okay, now I need to actually do the regression to find the function. So I'm going to go to Menu, Analyze, Regression, and I want a sinusoidal function. And it'll pop up. You can move your scroller and like click and hold this and move this around so you can see the whole function. Okay, so remember, I'm looking for my A, B, C, and D values. We should be familiar with those at this point. So, also to get full credit on this question, or on this part on the common assessment, all of these numbers need to be rounded to 3 decimal places at least. Okay, so here is my A value, 22.212 times sine. So you can follow along there. I'm going to go back to my calculator and then come back to the page once I've finished writing it. So sine, and then in parentheses 0.513. I can't see the end of this. I'm going to pick this up and move it. So 0.513 times x. Whenever you see this plus minus thing right here, they're saying plus a negative. So what this means is 0.513x minus 1.671. Okay, and then my last value, my D value, plus 50.981. Okay, so I'll pan back to my document, and you can see the whole function in all its glory. Okay, so that's a full credit points right there. The sinusoidal function with all of my parameters rounded to at least 3 decimal places. Okay, part B, based on your model, that's key. You have to use the model that you created. Even if your model was incorrect, if you correctly do this part, you would get these points, even if you didn't get that point, based on like a follow-through. You're correctly using your own model. Determine the following values and be sure to indicate units. Okay, amplitude, I know, is the absolute value of A in my function. Well, in my function, that is 22.212. Amplitude is measuring in the y direction. It's the measurement between the midline and either a maximum or a minimum. My y-axis was measured in degrees, so this is 22.212 degrees Fahrenheit. Okay, my period, I can't directly figure that out from my equation, or from my model, but I do have an equation where period equals 2 pi over the absolute value of b. And I know what b is from my equation here. So I'm going to come off to the side and plug in b and then solve for p. So p equals 2 pi over the absolute value of 0.513. And now all I need to do is plug this guy into my calculator and see what I get. Okay, so I'm going to go back to my calculator page. I've got 2 times pi over 0.513. So I've got 12.248. Okay, so that's my period, 12.248. Okay, the period is the measurement in the x direction. It's how long it takes for one cycle to fully complete. So my y-axis was measured in degrees Fahrenheit. My x-axis was measured up here in months. So 12.248 months for this cycle of temperature to complete. Okay, my maximum value, I can find this by doing D plus A. Okay, my D value for my equation is right here, 50.981, and my A value is 22.212. So let's plug that in our calculators. 50.981 plus 22.212. So I get 73.193. Okay, and this is a maximum value on the y-axis, so this is also degrees Fahrenheit. So the maximum temperature for Boston, Massachusetts, remember this is what my model is doing. It's modeling temperature for the year in Boston, Massachusetts. So according to my model, the maximum temperature every year in Boston is about 73 degrees Fahrenheit. Okay, for this part you'd have to have all three of these rounded to 3 decimal places, of course, and units on all three of them. Okay, our last part. According to school board policy, kindergarten students can only go outside when the temperature is above 45 degrees Fahrenheit. Using your model, so again, you have to use the model that you created, determine all values of T for which kindergarten students will be allowed to play outside. Remember, they'll only get to play outside if it's above 45 degrees Fahrenheit. And be sure to report your answers correctly to 3 places after the decimal. Okay, so easiest way to do this is I'm going to go into my calculator and I'm going to actually graph my function. So I'm going to create another page by going Control Document and adding a graph page. And I'm going to type out my model that we created here, so I can actually see what this entire function looks like. 0.513 times x minus 1.671 outside the parentheses plus 50.981. Okay, I hit enter and I can't see it, so that means I should mess with the window. So let's think through like what size window would make sense. Well, for my x values or my t values, I start at 0 and I go to 11. So that's probably a good window there. For my y values or my temperature values, remember this is T and this is temperature. Well, we said my maximum was 73, so let's pick 80 so we can see the whole thing. And I don't see anything lower than 0 on my table up there, so let's put 0 as the minimum. And let's do that for our window. And let's see if we can see the graph now. So 0 to 11, and then 0 to 80. There we go. Looks just like my my regression model. Okay, so I'm going to move that out of the way. Okay, so we need to figure out when the kids are allowed to play outside. Well, they're allowed to play outside when it's above 45 degrees. So here's a really simple way to do this. I'm going to graph another function at 45. I want to find out where is it at 45. So there's 45 degrees. So that point right there and that point right there, those are the 2 points in the year where it is 45 degrees, or where my model is estimating to be 45 degrees. Okay, so kids are allowed to play outside where it's above 45 degrees Fahrenheit. So that would mean on my blue graph, my model, all of this time right here of the year, kids are allowed to play outside. So between this point and this point up here, kids are allowed to play outside. So I should find out what these 2 points are. Okay, so in order to do that, I'm going to go to Menu, Analyze Graph, and Intersection, and then you get this dotted line where you can move. Go to the left of this point, and then to the right, and it'll pop up. So it gives me my t value and the temperature that it's plotted at 45. And I need to do this again for the other point, to the left and to the right. So it gives me my 2 values between this t value and this t value. Okay, so let's report really quick. Between my t value of 2.726 and 9.910. Okay, so let's write out what our actual answer is. So between t-values of 2.726 and 9.910 kindergarten students can play outside. And there's my final full answer with my answer, my two values rounded to 3 decimal places and described in context. So here I'll show you a snapshot of the whole thing now. And there's the whole problem with full credit being given on all parts.